Okay, I started recording, and we are going to look at the theory for amino acids and proteins. Let me also share video. Okay. The amino acid functional group. So there's one common structure for the amino acids functional group. So you have a carbon that carries a COOH bond. That's the acid part. That's the functional group for the acid. You have a NH2 that is amino group. So we have the amino acid and also a hydrogen. These three groups attach to same carbon. It's common among all amino acids that you have. The difference between one amino acid to another compared to another amino acid is in the R group. Now, your R group, it can be hydrogen, it could be a methyl group, it could be a phenyl group, it could be hydrocarbon, it could be amine, it could be alcohol, it could be carboxylic acid. If the R group is neutral, so it's either hydrogen or if it's a hydrocarbon, then your amino acid is going to be neutral. If the R group is another carboxylic acid, then the amino acid is going to be acidic. If the R group has any basic functional group like nitrogen, then your amino acid is going to be basic amino acid. So what do you think of glycine and alanine? Are these neutral, acidic, or basic, these two? Okay, let's look at it one more time. COOH is part of the functional group, so it has to be there. So for both of them, you have COOH. NH2 is the basic functional group, but is the same for both of them. Hydrogen is the same for both of them. And then the R group for glycine is hydrogen. For alanine is a CH3. What determines these amino acids to be acidic or basic is the nature of the R group. So basically either hydrogen or the CH3 here. If this R group is acidic, then your molecule or amino acid is going to be acidic. Hydrogen is not acidic, and CH3 is not acidic, so it's actually going to be neutral. So these two amino acids, they are neutral. They are one of the simple ones, and they are both neutral amino acids. Protein forms as a result of formation of bond between amino acids. So if two proteins, they form bond, basically condenses the two hydrogen from NH2, let's say take a OH from glycine, forms water, a hydrogen from NH2 and then H from the glycine, it forms water, so OH and H, and a new bond forms that is called peptide bond, a bond between two amino acids. So OH from glycine with one hydrogen from the amino group from alanine is going to form water. And then there is a new bond between a carbonyl carbon from glycine with the nitrogen from alanine. This bond here is called the amide bond or peptide bond. Formation of amide or is a peptide bond in biochemistry is peptide bond. In organic chemistry is the amide bond. So when you get two amino acids together, so the dashed line between this abbreviation of glycine and alanine, it shows that there is a bond between glycine and alanine. Now, these complex is basically called a dipeptide. If you have 3 amino acids, it would be tripeptide. More than that is going to be polypeptide. And then when you have enough of those combining together, it's going to give you a protein. So today's experiment is not the study of protein. So what is basically doing is trying to distinguish between proteins and the amino acids. You already took the quiz, and since the quiz is like open book, I was very detailed in making the multiple choice questions. I was trying to help you to go back, study, and then you had to go back like 3-4 times at least to like top 2 page of the introduction that you had for this experiment. And I was hoping that today when you come to the lab, you have an idea what we are trying to do. So by making the multiple choice a little bit more detailed, just saying what is each of these tests indicates, or a positive test or negative test, what does it mean actually? So the first test that you're doing, what is the first test you're doing? Your first test is going to be Bayreuth test, right? This test is going to distinguish between proteins and amino acids. In a basic solution, if it gives a positive test, what does a positive test means? Okay, so amino acids don't react with this, only protein would react with it. Protein with 2 or more peptides is going to react with, and the color of the reagent is going to change from blue color to pink color. So if the color of any of the unknown, so we are just going to, just like carbohydrates, we're going to have like 4, 5, or 6, maybe 5 different test tubes. We are going to label it, and to all of them, we are going to add the reagent. Anything that changes to pink color, then we know that is a protein, is not amino acid. So we identify that. So since we know that the protein is going to be the albumin, then we know that we have, has a name for it. So it's albumin. So second test. So the first test is going to distinguish protein or albumin among all of them. So as soon as you have positive for, let's say, your test tube C is albumin, then you leave that. Then you only work for the next 4 test tubes. The second test tube, the second test is going to, we are going to add the nitric acid. And then when you add the nitric acid, if the R group in the amino acid is aromatic ring, then yellow color is going to appear. So when we add nitric acid to the next 4 test tubes, any one that changes to yellow color, it means that the name for that is going to be tyrosine. Why tyrosine? Because the only amino acid of the 5 or the 4 amino acid that is left is going to be that contains the ring, aromatic ring, is going to be the tyrosine. So we only we identify 1 amino acid there. So we are done with the one that is albumin. We are going to be done with the tyrosine because we are going to do the nitric acid test with that. If the yellow color appears, then we know that we have tyrosine positive. Then we do the sulfur test. The sulfur test, we are going to use a strong base again in the for the solution of the amino acids. If the R group contains sulfur, then we are going to get what color? Do you remember the color? So we are going to get, then we know we have cysteine if we get the positive positive test result with the for the sulfur test. Okay. Then we can identify 3 already. Okay. So if we have tyrosine is going to be yellow color with nitric acid. If it's the pink color, pink violet color, that would be the albumin, and then you have your cysteine also identified if you get a black precipitate. So if you see black precipitate, then you know you have cysteine. Okay. What's your next test? And we have 2 more left. Glycine or glutamic acid. We find the pH. If the pH of the amino acid is less than 7, then we know that is the acidic. And if it's not less than 7, then we know it's the neutral. So glycine would be the neutral amino acid, and the glutamic acid is going to be the acidic. So we just check the pH, and this way we can identify 5 amino acids. So the group this is just showing the R group. Just imagine this carbon. There's a carbon here attached to another COH, 1 NH2, and 1 hydrogen. So this is just showing the site or the R group that is attached to the amino acids. Cysteine is going to give positive test with the sulfide. Yeah, you have, this is going to be tyrosine is going to give positive test with the aromatic because it has aromatic. Glycine would be the last one that is going to be neutral and left as the last one out of the 2 that we have. Glutamic acid is the one with the pH, acidic pH. And the cysteine is going to give you black precipitate. The okay, which one cannot be amino acid? Is A amino? Why A is not amino acid? You tell me why A is not amino acid? Because A doesn't have hydrogen. A doesn't have hydrogen, so it cannot be amino acid. If you had 1 hydrogen here attached to the carbon that carries the acid and the amine group, if you had the hydrogen here, it would have been amino acid. B, is B amino acid or no? No. Why B is not amino acid? Because it doesn't have NH2, right? B doesn't have NH2. B is the one that I'm showing here. If you can, I don't know if you put what you see. So B, there's OH, hydrogen, CH2OH, and COOH. Nothing wrong with the COH, nothing wrong with the H, nothing wrong with CH2OH, but we cannot have OH and not have NH2. So we must have NH2 also attached to the same carbon. So B is not amino acid. What about C? Is C amino acids? C, you have the acid functional group, you have the from the pre-lab, not the quiz. So C, there is a NH2, there is a COH, so those are fine. Then what else do we need to have? We need to have a hydrogen, and we need to have R group. There is no hydrogen attached to this carbon. For C, there is a carbon double bond, so that's why C is not amino acid. D is amino acid because you have the 1 carbon, you have hydrogen attached, you have NH2 attached, and you have COOH attached. So D is the amino acid. The R group could be anything. but you have to have the other three always the same. So the other three groups must be the same. Okay, procedure. Are you going to tell me what to add if I close the procedure page? Do I need to turn on another computer for this, or can you help me with this? You can? Okay, perfect. So I am going to take, apparently we have 5 unknowns, so I'm going to label A through E and take 2 milliliters of unknown in each large test tube. And then we are going to make that basic solution and then add the copper sulfate. We are adding copper sulfate in basic solution. So let's do the test 1. So I'm going to stop sharing this. So we go back to video. And I will take the, okay, start boiling water. Thank you. Going to start boiling water. Do we need boiling water for every test? Or that's for later? You need it for B and C, okay? So we can start with the part A. So we have I have the label for A, B, C, and I need the label for E, and I have also B. Okay. I'm going to measure the first one as usual. Going to measure with 2 milliliters using graduate cylinder in A. And then hold the test tube B next to test tube A and add enough to make it 2 milliliters. This is not good. So it's not good because I hope it's not old. Because it's not dispensing. I hope it's not old, but it should work still. It should still work. Okay, okay, 2 milliliters for E. I need 2 milliliters of C. Two milliliters of unknown D. And I need 2 milliliters of unknown. Unknown. Okay. So you want to make sure there is no settlement here. And next, %10 sodium hydroxide. And are we adding 2 milliliters of the sodium hydroxide? Perfect. 2 milliliters of sodium hydroxide to each one. Okay, 2 milliliters for D. Now we're going to add the copper sulfate, 5 drops. Adding 5 to each. Okay. Going to leave it like this. You could take a screenshot because I want to bring it up and make sure that you can see the labels. Okay, you see the label. And now you see the colors also. So which one is the protein? Albumin? Okay, so albumin is B. Now we are going to do test 2. The second test, we already know, we have identified one already. For the second one, need to get test tubes. Again, new test tubes. So you also that there's only one that gave you pink color, right? A, C. Okay, so procedure. So B is the albumin. Procedure for the next experiment? Oh, perfect. Okay, 2 milliliters of the unknown. And add the nitric acid. Okay. If the yellow color appears, we don't have to add we don't have to do the hot water bath. Okay. We will use the hot water bath only if it doesn't appear. You don't see the problem. Need to save something. I have been burned by the nitric acid in the past, so every time I hear nitric acid, I run for the for gloves. So A, 2 milliliters. B, I don't have to do B, right? B, I don't have to do it. C, because we already have a name for B. 2 milliliters of C. 2 milliliters for D and 2 milliliters for, and yellow color is going to be, if it turns yellow, then we have tyrosine. Okay. And we're just adding 10 drops, right? We're just adding 10 drops of the nitric acid. Okay. So make sure you see what I'm doing. There is, the fume hood is off, unfortunately. But it's supposed to be on. Okay, going to add 10 drops of the nitric acid to each one. And what color are we looking for? A yellow color? No. So that's A, C, D, and E. I think E is yellow enough, right? E is yellow enough, and we don't have to do the hot water bath for this part. Okay? So unknown E is the only one that showed the yellow color. So you can identify, based on the theory that we looked for this test with the nitric acid and the evidence of yellow color. Now we are left with B and E identified. A, looking for A. C and D. Okay. A, C, and D. You have a procedure for me? What's the next part? We're going to do the sulfur test. And based on the sulfur test, we can okay. So procedure first. So if we have positive, we continue. If we have negative, we continue. If it's positive, we already have identified the B and E. So with the other three, we're going to get the 2 milliliters of the original solution again. Perfect. Thank you. Thank you. 2 milliliters of the unknown. Unknown A, 2 milliliters. Unknown C, 2 milliliters. Unknown C. Unknown C is 2 milliliters. And unknown D. And next, we are going to add 4 milliliters of sodium hydroxide to each test tube. The sodium hydroxide is inside the fume hood, so we're just going to take 4 milliliters and add to each one. Four milliliters sodium hydroxide. To So we place in hot water bath first, and then add the lead acetate. So we're trying to find the cystine this time. Yes? Yeah. Anyone that any of those test tubes that is going to give us dark color, it means that you have lead sulfide, and the lead sulfide is the black color. So bring the lead from lead acetate, and the sulfide is coming from the amino acid. The only amino acid that has sulfide is going to be the cysteine. And that's what we are trying to find. Okay, how long should we wait for the positive color? Or should we look at it as soon as it turns the black color? As soon as the black color appears, we can stop the heat. Okay, we have A, C, and D. When I hold it next to each other, you can take a screenshot and you could also compare the color. You might find the okay. A has the black precipitate in, so you can take a screenshot of this and you can record positive tests for the one with the black color, which is A. Perfect. Okay. Next, so what is left? C and D. Okay. I take two test tubes with one for C and one for D. Need to test for pH. To test for pH, we are using a pH meter. So before we use the pH meter, because if it's left, especially if the cell that is going to be placed in the solution, if is dry, it doesn't show the proper number. So every time we use it, we have to, every time we need to measure pH, we need to first calibrate the pH meter. How do we calibrate pH meter? We basically tell the machine that we have a buffer solution. The buffer solution, these are manufactured. We order them with exact pH. This one is a 7.00. So we already know the pH for this solution is 7. So when we use this cell, we place the cell inside a solution in a beaker with a solution of pH 7. Then we press calibrate. Basically, we are telling that any solution with this pH is a pH 7. So now it's your turn to tell us what is the pH for the solution for the proteins that we are trying to test. So I'm going to pour about 30 milliliters into a small beaker because I want to make sure that the pH, the cell for the pH meter is immersed inside the solution. So I can't have very low. So we place that inside a solution. We turn it on. Okay. The instruction tells me to press the standard once to make sure that it's trying to calibrate and then press enter to take the pH. Now, the sulfur, the pH meter is calibrated. We can now go ahead and use it's ready to be used with our solution. So I'm going to test one solution at a time. So we're going to take the pH. In the test tube, we can't do the pH. We cannot measure the pH inside the test tube. So we have to place it in a small beaker. And we're dealing with C and D, unknown C. Going to do one unknown at a time. For unknown C, I place the unknown inside the small beaker, a 50 ml beaker. And I'm going to read the pH. The pH for this solution we get this situation. The battery is low and it just gave me a message of low battery. But the good thing is I have another pH meter. I'm going to take it, calibrate, and continue. So I have to change this because it doesn't have the battery. It was on, and then it just gave me a message of low battery. It says low battery, so I'm going to change it. Use a different. So I got a different pH meter. I placed the cell inside the beaker and read the pH. This is the pH is 6.99. So the pH is 6.99. That means it's very close to neutral, but we have to first test the other one. So pH for solution C is 6.999. Record that pH, please. And now we're going to try with the pH of the solution D. pH for solution D. Right. 3.88. pH for solution D is 3.88. And because the pH is acidic, this amino acid is an acidic amino acid. And out of the choices that we had, the acidic amino acid is going to be the glutamic acid. Did you take a screenshot of using the pH meter? Or no? No, right? Okay. I want you to just take a screenshot of using the pH meter. Take a screenshot, please. Put the monitor down. Sure, sorry. Okay. Does it work now? Better? Okay. Take a screenshot, please. Okay. Any questions? Anything that we missed or we didn't do part of the experiment, or you didn't get the evidence? Because my point is for you to get the evidence and not the name for the unknown here. So the name of the unknown is your responsibility to go back to the lab, read the procedure, because it tells you if you get like black precipitate, what is going to be the name for that amino acid. If you get like pink violet solution, it's going to be protein, is not amino acid. There is a peptide bond there. So all I'm concerned for you at this point to make sure that you record the evidences for each of the unknown. What was the evidence? And the best scenario is for you to go back to the procedure and match the evidence with the information that you have in the either in the introduction part or the procedure, in order to identify your unknown A through E. Okay, any questions about any parts of the experiment that you didn't record the evidence, or what happened? Just want to make sure you have the evidences. Perfect. Any question in general? Grades. Grades are going to be calculated according to the no, 13 is not going to be on the test, but I guess I have said it. If I said it, then yes. So the grades are going to be calculated based on the syllabus. D2L has the raw scores, and then I take it and I do the calculation based on the questions that based on the grades and the scale that you have for syllabus. So if it says 12 assignments, you have 13 assignments, the lowest grade is going to be drop. And it's better to make sure to make sure that you have a backup plan. Make sure you turn in your assignment for 13. Do not assume that 13 is going to be the lowest grade for you. So in case you have higher grade for 13 and you have one assignment with the low grade, then that one is going to be dropped. So you turn it in, and when I grade it, the program actually, the D2L is going to pick the lowest one to be dropped. Or if it doesn't, I drop it myself, and then I would calculate the grade based on 12 assignments instead of 13. That's true. Yes. Okay. Any other questions or concerns? There is no, if you have submitted, it's not a missing grade, it's just not being updated yet. And I'm working on it, believe it or not, I am working on it. And I'm just writing one test for, let's say, I write a quiz for your class and then grade, let's say, one assignment or two. And then I go to my next class, write a quiz or test and grade one assignment or two. So I haven't finished it all. I will finish it all. So make sure that you download the honor log. Yes, the honor log, and take a practice test with it. Yes, you take a practice test. The test is going to be exactly at 5:30. We're gonna start. You can start at 5:30. You can start at 5:40, but it has to finish during the lab time. So it has to finish before 7:20. A periodic table, yes. Number of questions, I've been writing like 25 questions, but for your class, it's going to be less than that. 20 questions or less, between 15 to 20 questions, yes. Okay, since you don't have questions about the actual experiment, I'm going to stop the recording, but we will continue. I'm going to continue talking about your concerns and any questions that you have in general. So because I'm labeling this as a experiment 13, I don't want it with experiment 13 plus all concerns and discussion. So I'm going to stop the recording.